Hey guys, it's your old friend Pythagoras here. I've been busy working on my theorem over in ancient Greece. Let me tell you a bit about it.
Here is a right-angled triangle with sides length A, B and C, the longest side C being the hypotenuse. If squares are made on each of the three sides, they will have corresponding areas A squared, B squared and C squared. The biggest square, the green one, has exact same area as the two smaller squares put together. This is Pythagoras' theorem, A squared plus B squared equals C squared.
Fun fact time! None of my findings are ever actually written down, so one of my mates could have come up with this theorem, but I guess I'll take the credit anyway.
Take a right-angled triangle with hypotenuse length C and other sides length A and B. Make a square using 4 of these triangles. The length of the sides of the largest square will be A plus B. This means the area of the large square equals A plus B squared. The length of the sides of the small middle square are C, so this means the area is C squared. The area of each triangle is half the base times the height, so half AB. So we have that the area of the big square is equal to the area of the smaller square plus the area of the 4 triangles. So A plus B squared is equal to C squared plus 2AB. Expanding this, we get A squared plus 2AB plus B squared equals C squared plus 2AB. Taking away 2AB from each side, we are left with A squared plus B squared equals C squared. Alternatively, by moving the triangles around, we can show that the area of the middle square, C squared, is equal to the area of these two squares, which is A squared plus B squared.
Fun fact time! I really thought my ideas were pretty darn good, so I decided to start a cult dedicated to sharing my wisdom. They were called the Pythagoreans, and I was the father of numbers.
So why is Pythagoras' theorem useful? If we have a triangle and we know the lengths of 2 of the sides, then we can use Pythagoras' theorem to work out the missing length. This little guy has got himself in a sticky situation by accidentally setting his house on fire. The firemen need to work out how far away to place the ladder from the house if they are to reach the window and rescue him. The ladder up against the house makes a right-angled triangle. The window is 4 meters high and the ladder the firemen have is 5 meters long. So we know that C, the hypotenuse of the triangle, is length 5 meters and the other side, called that A, is 4 meters. Using Pythagoras' theorem to find the missing length of the triangle B, we get 5 squared is equal to 4 squared plus B squared. Rearranging this, we get 5 squared minus 4 squared equals B squared. So B equals the square root of 25 minus 16, which is root 9, which is 3. So the ladder must be 3 meters away from the house. Here is a more difficult example using a bit of algebra and quadratic equations. We have a right-angled triangle with hypotenuse C, length 3 root 5, and other sides A and B of length x and x plus 3 respectively. Let's find x. First we substitute the lengths of the sides into Pythagoras' equation to get x squared plus x plus 3 squared equals 3 root 5 squared. Then, expanding this, collecting the like terms and dividing the equation by 2 to simplify. We are left with the equation x squared plus 3x minus 18 equals 0. Then factorise this quadratic equation into x plus 6 times x minus 3 equals 0. This gives us either the solution x equals minus 6 or x equals 3. But the length of a side cannot be a minus number, so we know that x is equal to 3.
Fun fact time! I'm a vegetarian, as I believe all living things have souls. Also, I refuse to eat beans, or even touch beans, as they're made out of the same materials as humans. Ah, beans!
Another shape that Pythagoras shows up in using circles. Take a right-angled triangle, sides length A, B and hypotenuse length C. We can make 3 circles of radius A, B and C respectively. Now we recall the area of the circle is pi r squared. Using this, we can work out the area of the yellow circle is pi a squared, the area of the red circle is pi b squared, and the area of the green circle is pi c squared. We can take Pythagoras' theorem and multiply it through by pi. Notice that these are the same as the areas of the circles we just calculated. So this tells us that the area of the yellow circle plus the area of the red circle is equal to the area of the green circle.
Thanks for listening. Don't forget to join my cult.